Hello and welcome to this live technical discussion series. And today we are going to talk about geotechnical investigations. And of course, it is a very vast area. And as in our country, the infrastructure growth is likely to increase exponentially, we can say. Yeah, likely to experience, or rather we are going to experience a huge growth. And because of the land scarcity, we are going to let's say execute or build the structure or the infrastructure in the relatively poor soil strata. So with these importance of geotechnical investigation is extremely important in such projects. And always there are a number of questions like what are the tests we require with respect to, let's say, field test, with respect to laboratory test, how to interpret those kind of results, and what are the advanced technologies which are available. Okay, and accordingly, we have received nearly 250 plus interesting questions on these subjects. So we will be exploring to have this kind of a discussions in a future also. But at least in this part, we'll be attempt to cover at least a few of the queries whatever we have received through the registration form. So Saurabh Gupta will join us shortly for this very interesting discussion. Okay. Okay, and you can share this live stream in the relevant group so that we can receive the diversified input from the participant. And just as a small announcement that recently, based on request of a student, we have launched a special series for the students focusing on, let's say, the specific requirements like career development, training related to software. Then there are so many questions which we have received from the students. So we have just launched that special series for the student, and the link is mentioned on the scrolling text. So if you're interested, you can just visit this link. And the first session is scheduled on 9th February 23. So you all will be able to interact with us through the live chat. Okay, so welcome Sandeep ji. Sandeep Deshpande has joined. Okay, so let's get started. Yes, welcome Saurabh ji.
Hello, everyone.
Yeah, so I
Thank you,
was
Mr.
just
Bhavan, for having me here.
most welcome, most welcome. So I was just telling them that we have received 250 plus interesting questions on geotechnical
Wow.
investigation. In fact, I have not shared, the last update. There are still, questions were popping up. So the first lot was only part summary. The questions were still coming up. Okay.
No problem, sir. We'll try taking up as many as possible, and then we can always have
Yeah,
further sessions if required.
yeah, sure. That's good. Okay. Okay, so we'll have short presentation, and thereafter we will be taking up question and answer towards the session. But you please feel free to put up as many questions or discussion points during the session. So we will keep on collating those points, and then we may be discussing some of the points in between the session, or we may take up towards the end of the session. Yeah. So over to you, Saurabh, now. Yeah. Yeah.
All right. Thank you.
Yeah.
Let me know when you have presented the slide.
Yes.
Oh, perfect. Thank you. Uh, okay, so good evening to everyone. Uh, as Mr. Bhavan rightly said, I think as our country is moving forward, and we are, the importance of proper geotechnics in infrastructure development has increased. Uh, as we are spreading out, many of our construction sites, it's not like the good old days where we used to find good land and you can construct on it. These days, through sheer growth and economics, a lot of development is happening in areas where the soil is quite complex or quite poor for construction, and this is a challenge for budding geotechnical engineers, structural engineers, on how we can work with such ground conditions and how we can optimize foundation cost. Uh, I'll get into it. This is a small guide which we are prepared at Senjas. It's a guide to better geotechnics. It's a work in progress, and with interactions, we'll keep updating this. Uh, a little bit about how we will formulate the presentation, and I think I'll take about an hour, hopefully, to go through the content, and then we can do Q&A. Uh, you know. So first, I would like to introduce you to my company. It's Cengrs, CENGRS. It's an acronym for Civil Engineers. Many people don't get that. Uh, so we are an old company. The company was founded in 1990, and it's led by IIT Delhi alumni, myself included. We are now, in fact, this is an old slide. We are now about 200 people, and we have carried out over 6,500 investigation projects across the length and width of the country in the last 32 odd years. We do work, of course, as geotechnical engineers. We get an opportunity to work in different segments in all kinds of projects, from power plants to buildings and factories, and we have carried out the length and width. In terms of service offerings, I'm not going to go through this. A lot of this is available on our company website, but it should suffice to say that almost every kind of modern geotechnical investigation technique which is out there, we carry these out in house. We are very much interested in pushing the envelope as a company. Our motto is to always push the envelope and try to bring in new technologies which are successful all over the world, bring them to our country, so we can be self-reliant and we can do carry out the best practices from all over the globe. In terms of geotechnical, geophysical, foundation testing, these days we have a lot of tools which are available to us for proper characterization. We also take up consultancy jobs. So we take up a lot of analysis projects, whether it's Plaxis analysis or slope stability, hard stand design, and so on and so forth. This is our management. We are led by Mr. Sanjay Gupta, Mr. Ravi Sundaram, and myself. We are the three technocrats spearheading the company, supported by a strong team of geotechnical engineers. We are very active, and I think this is important. I encourage more and more of us to actively participate in professional bodies. There's so many of them. The Bureau of Indian Standards, has many committees where we can upgrade the codes. Indian Roads Congress, IGS, ISSMG, DFI. I do encourage all the participants to sign up for these professional bodies, because this is where we can interact as professionals, learn from each other, and contribute to the profession as well. I would like to announce, in fact, one of the latest developments is some of you might have heard of NABL. Traditionally, many of the geotechnical consultants adopted NABL for the laboratory. Starting 2022, I think we are one of the first companies. We have extended the range or the scope of our NABL accreditation to cover the entire spectrum of our field activities as well. And this is pertinent because we genuinely believe that a lot of the strength of investigations really comes from the field testing, possibly a bit more than lab testing even. So quality assurance and control on sites becomes very, very critical. I do believe we are one of the larger databases, geotechnical databases in the country, and I am keen to to work with. If you have any GIS experts, please contact me separately. I'm keen to put all this data together, hopefully sometime in the past, and develop a subsurface model for the country. We don't have that yet. I think this is something which will be good for all of us. I'll get into it. We keep talking about good and bad geotechnical engineering. I would like to talk about, in our opinion, what is good geotechnics. Uh, there we believe there is no such thing as difficult ground. Uh, if you have a site which may not have the best soil conditions, which might have some challenges, liquefaction or slope stability or so on and so forth, don't be disheartened, because just like the Rubik's cube, the puzzle is only as hard as the person who's solving it. So if you have the right team with you, the right consultants, then a lot of these problems can be solved very easily. This is something I borrowed from a friend of mine called Chris Haber, and in Australia, and they talk about levels of geotechnical input, and we'll get into this. We like to characterize uh, levels of geotechnical input in terms of bronze, silver, gold, and platinum. And the theory is, depending on your project use, if you're working in a low risk project, maybe you're building a small G+1 building in a relatively stable soil condition, then maybe you can carry out a very basic investigation consisting of a couple of boreholes, some basic lab testing, and with local experience, you can get some fairly good uh, uh, estimates of bearing pressure and so on and so forth. However, if you're coming up with a high risk project, and I define high risk as either the structural demand is fairly high relative to the soil conditions, then this is the best way forward is to work with your geotechnical consultant, work out, maybe carry out a staged investigation. You can do a preliminary investigation, get some basic data, understand where we stand, run some numbers, and then we have to work together, and we must carry out a detailed investigation which has to be tailor made for that project. And the reason I'm emphasizing this is because the scope of geotechnical investigation must never be a copy paste job. I see a lot of inquiries and RFPs where it's just the same thing copy pasted without any thought about what we are building, where we are building it, what are the challenges we might expect. It has to be an iterative process. We have to design the scope of the investigation for each project, and the better we do it, the better the outcome, better the optimization and foundations, better the economy. And we always like to say that you get what you pay for. It's important. And which is, it's documented all over the world. If you spend on proper investigations, you spend on proper testing, you plan it, you design it, you implement it, you are going to see a lot of saving in terms of project schedules, in terms of project cost, and also risk mitigation, which is very important. A lot of our Indian projects, although we are moving forward, we are routinely seeing issues at site during construction, reinvestigations, redesign, additional piles, and all of these things can be avoided if you get the right guidance beforehand. This is also a study which was published, and you will see, and this might seem remarkable that if you spend more on proper ground investigation, it makes sense that then naturally you're going to see a lot of ROI in terms of saving in construction cost. At Senjus, we have actually documented a lot of case studies where we have done this, and we have actually shown ROIs of as much as 100 or 200 times the cost of investigation, pure just in foundation cost saving. There are many areas of improvement, and I will not have time to go through all of these in detail, but a few of these let's pick out. How can we improve the way in which we are working today? This is a cartoon I found on the internet. I see a lot of students these days, especially recent grads, who are working with very advanced, softwares and finite element models. There's Plaxis and FLAC, and they're running all this analysis. And maybe as conventional ground engineers, we always like to remind them that, garbage in, garbage out. So before we get into advanced investigation and advanced analysis techniques, we have to understand the data which we are entering into the software. We have to understand where the data is coming from, and we have to ensure that the data is accurate. If you go to a doctor with the wrong blood test report, there's nothing the doctor can do for you. If, so first step should be to get the right test results, and this is what we are emphasizing on today. In terms of tools, as I explained earlier, and we will talk about this in detail later on, these days there are a lot of techniques which are available, some better than others, some more pertinent to your project site than others. So as I said earlier, you have to tailor your approach, you have to tailor your scope for your project. And as a company, we are always keen to work with customers for this. Many people come to us without a scope, and they come to us with a requirement, and we work with the structural engineers free of cost to work out a scope for the clients. And I'm happy to do this for any of you for your projects as well. SPT, so I will not get into this in detail, but you can see that using advanced investigation techniques, using field instrumentation, construction monitoring techniques, will definitely, this is an area of improvement here. I'm going to skip through a lot of this. I will be sharing the slide, but suffices to say that we do believe that although geotechnical engineering is a science, its practice is an art. So please, when you define, when you try to define the scope of your investigation, scope of your pile testing, work with a geotechnical consultant who can guide you properly on what needs to be done. And we all know about the Leaning Tower of Pisa. I think had they planned the investigation properly, it would not have been one of the wonders of the world. They got lucky. A lot of structures are not so lucky, and they simply topple. So let's not take that as a benchmark for us. This is what I said earlier. Just like there is a difference between a diagnostic center and a doctor, there is a difference between a soil investigation agency and a geotechnical engineering consultant. And these two are not always the same. There are several companies where, like ours, where they have in-house expertise to carry out investigations as well as consult on the project, but not all. These two don't have to be the same. We do emphasize that once again, the approach must be finalized with the help of a geotechnical consultant. The actual investigations must be carried out by a company which has got strong processes to ensure that the data quality and consistency is there. And please, I know we say this in all the forums, and I understand the limitations, but for your next project, try to avoid the L1 technique of selection. Do select your consultant, select your investigation partner based on their profile, based on their expertise, and based on what you're going to get out of it. Remember, the cost of investigation for most projects, in India at least, is usually less than 1% of the project cost. And the impact of this investigation is directly on 10 to 15% of the project cost, which is the foundation cost. So it's simple economics. You have to make sure you are right the first time so that your project doesn't get to go in the wrong direction. As I said earlier, a planned SI program can lead to 50 to 100 times, and this is conservative savings in terms of the foundation cost and risk mitigation. You talk to any economist, and they will say that this is a no-brainer. Again, your one shoe does not fit all. We have to design these investigation scope for each project specifically, take into account local experience, take into account prior experience in the area, and have a discussion at the beginning of the project, not when everything is done and we're already having problems. Again, it's a spoof on the Leaning Tower of Pisa, and history shows that they did try to save on the cost of investigation, and things did not pan very well for them. We have discussed this before. Especially these days, we are finding a lot of RFPs where the scope is either insufficient or just purely incorrect, or not applicable for the project site. And we do try a lot to work with the customers and give them feedback on what needs to be done. But this is something which we all have to work together on, and make sure that we use our brains at the right time. This is just a point that I think a lot of the audience today consists of structural engineers as well. I think we are going in the wrong direction in our country today in many projects, wherein the owner or the PMC or the architect will normally define the scope, get a soil report, and then dump the soil report on the structural engineer, and the structural engineer works off the soil report. There is no interaction between the SC and the GE. And I think this interaction, no matter what is the size of the project, this interaction between the structural and geotechnical engineers, this is very important. There has to be several levels of this interaction. The first must be at the concept stage. Owners must try to bring their consultants together on day one, have a brief discussion. We should understand each other. Geotechnical engineer consultant must understand what the structural engineer needs, what are they building, and this interaction has to go through all the way till the end. Even when the soil report is submitted, there must be a one-on-one interaction between us to really understand the recommendations. If there are any modifications, any changes in size, depth, then these things must be done at the design stage. And lastly, no matter how hard we try to do things well on paper, there is always a chance that the translation of that design on site is not done right. And this is very important, especially for foundation construction, because you can't see what you're building. Everything is under the ground. Everything's hidden from your eyes, and very few people understand this. So many projects, I cannot tell you, hundreds and hundreds of projects are suffering simply because of poor construction practices, ignorance at site, and it's a lot of time and money and energy being wasted on these very, very simple repetitive mistakes. So it is important to avoid that. Again, we do emphasize that for your foundation construction, do involve your geotechnical consultant all the way through until the construction, at least the foundation construction, is completed successfully. Because it should not be that you have one soil investigation wala and you have a different foundation testing wala. That should not be the case. We have to change the way we approach projects. Many of the contracts I see, especially for deep foundations, the testing of the piles is included in the scope of the piling contractor. Now, this has never made any sense to me, because it's like school mein the, and you give an exam and you grade yourself, and obviously everybody would be 100% passing in that case. So foundation testing must have a separate spec, and ideally it should be done by a third-party agency directly appointed by the owner. So that was a quick overview. I think we've exhausted about 15 minutes. I will now get into some technical discussions. And this is the scope I made. I haven't picked everything. I've tried to pick only 5 or 6 points where I thought we can go into detail in terms of what are the advances in investigation tools today, and what should be done. Again, we are talking about good geotechnics. This, in our opinion, is what should be done. We'll talk about processes for field and lab data quality. We'll talk about the SPT, better rock drilling, some in-situ test methods. I've just selected 2 for today, and geophysical methods and foundation testing. So let's get into it. Uh, Quality and processes. We saw this earlier, and I think there. Uh, I, this is just to illustrate. See, if you think about it, every investigation job, the quantum of data which is being collected in the field and in the lab is tremendous. Uh, if you want a solid, so again, I go back to, I always tell my customers that, hey, if you are giving, you're not feeling well and you give a blood sample to a lab for testing, will you take a chance? Will you go to for the cheapest lab, or will you go for a lab where you can actually trust the results of a blood test? Obviously, most of us would like to go to a lab which is trustable, which is reliable, and we should know that they have processes built in and they have systems built in where they can ensure consistent quality, and they're not going to give me the wrong results. uh, we should think about our structures the same way, right? At Sengers, for example, just to illustrate, we have built a lot of systems in house uh, to track, and this is part of our NABL intent as well. We track each and every sample, and typically on a site there might be 200, 300 samples which are collected minimum. So we have built fairly complex systems in house to make sure that each and every sample is tracked, tagged, and the timelines for testing and so on and so forth are all tracked in house. Uh, it is also important, and I think if you have a bigger project, this might be worthwhile. I have developed an Excel file also. Very often I see scope, maybe 200, 300 borehole scope, and the work is given to an investigation company, uh, and they're producing reports as well. But very often I find that if I do the simple math, I find that maybe the lab equipment is not even sufficient to carry out the quantum of testing which they're reporting. I will leave it to the knowledgeable audience to understand how that might be done. I don't want to get into this today on this forum, uh, but obviously there are, in every industry there are people who are cutting corners, and as a purchaser or as an owner, we have to be cautious, uh, to control and to understand, what are the things we need to see to avoid any issues later on. This is just part of due diligence. Instead of going for L1 technique, I think it's more pertinent that we should do due diligence on the investigation partner to make sure that they will treat your project like their baby as well. Let me stop here and see if there are any pertinent questions, Bhavin, or should I go on? I think I'll just go on. We'll take questions in the end. Uh, So I do want to talk about, we all know about the SPT, the standard penetration test. The SPT is a very simple test. Most of us know it. It just consists of dropping a hammer, 63.5 kg hammer by a certain height, and measuring, the number of blows it takes for a certain penetration of the split spoon sampler. It's a very simple test. It's very basic. Uh, but you know what? To be honest, there is nothing standard about the SPT worldwide. And I think as we go forward, we all are recognizing it. There are a lot of limitations of the SPT test. It depends on a lot of parameters, and it's very hard to do an SPT test right. Uh, we see SPTs being done left, right, center. We as most designers will hold SPT as the holy grail. What is the SPT value, and SBC based on SPT. It's a direct correlation between your bearing pressure and your SPT values. So this is really something which we need to think about. Now, one of the things which I highly recommend these days is, I think the SPT should never be done without an automatic trip hammer. What does the automatic trip hammer do? It's a very simple catch device. Now, you must ensure this on your projects. Anytime the SPT is done, it must have at least have an automatic trip mechanism. What that does is it ensures the height of fall of the hammer. Simple as that. Why is that important? If you don't take care, you have a regular, manual SPT system, what's going to happen is ultimately it's manual labor which is doing the work on site, right? So if they drop the hammer, they are not going to. The old practice used to be that they'll make a chalk mark on the SPT rods and they'll manually kind of eyeball it, and it's labor is labor. Your field staff is not going to be so conscious. Sometimes we'll drop the hammer from a low height, sometimes from a high height. Resultantly, your SPT values are going to be all over the place. And when the soil report comes, you can't trust the SPT values. How do you do your design? So calibrate your SPT hammer, ensure automatic trip hammer, so that you have consistent drop height, clean your borehole properly, use the right rods, use spacers. There's so many do's and don'ts. And if you do all of these right, you are going to get much better SPT values for your design. The next value add which we started doing, and these days we are doing this on all, I would say, most of our projects. This is a recent development. The SPT value which is used in almost all correlations, including the correlation for bearing pressures and pile capacities, is supposed to be N60. N60 means that it assumes that 60% of the energy is being transferred to the soil. And this is the baseline assumption for almost all correlations that we use. Until about a couple of years back, to be honest, none of us really knew what is our energy transfer ratio, because we never measured it. Now we have this tool, and I think a lot of geotechnical consultants have this tool. It's called an SPT analyzer. It's based on the PDA concept or wave mechanics. What we do is we connect this instrumented rod when we do the SPT. It's a field test. And this actually will measure your energy transfer ratio on the site. Why is this important? This is important because it makes a huge difference. For example, for our regular Shannon auger kind of rigs with automatic trip hammer, what we have found is that the ATR value which we actually get on site is as much as 70 to 80%. It's not N60. What we're actually measuring on site is maybe N80, N70. That means that supposing I measure an N value of 10, the actual N value for use in design would be 25% higher. And consequently, your bearing pressure would be higher. So this is the amount of difference it makes. If you measure your SPT energy, and on the other hand, so this is when your ETR value is more than 60%. On a lot of setups of using a calyx machine or rotary drilling rig with a manual hammer, sometimes we are measuring ETR values of maybe 30, 40%. That means that the N value which you will end up getting would be much higher than the right N value. Your design would be unconservative. There would be some risk involved. There might be some failures of the foundation later on. Makes a huge difference on your bearing pressure value. See, the bearing pressure, and I always like to talk about this. I think we sometimes confuse bearing capacity and bearing pressures. Bearing capacity is the ultimate bearing capacity is a strength parameter. That is the level at which the soil will fail below the foundations. But usually we talk in terms of stiffness. We are concerned about tolerable settlements, and we are limited by settlement criteria. The bearing pressures are directly proportionate to your N value or to your stiffness of the soil. There is no factor of safety here, which means that if you are inputting the wrong N value or the wrong stiffness parameter, the wrong modulus parameter, you will proportionately get the wrong bearing pressure for design. So this is just to say, not to underemphasize, I think getting the right data on site, you can see how important this is for everything that follows. I am not talking about better sampling. I haven't added the slides for this yet, but I just want to make a small note. I think the Shelby tube sampling is very much abused in our country. The emphasis in many of the RFPs is on number of samples, right? I think we need to change our mindset, and we need to change or shift the emphasis from number of samples or number of tests to quality of samples and quality of the test. If you take a rubbish sample on site if you've got hard strata and you're just pounding a Shelby tube in that hard strata, you are not going to get reliable lab results out of it. You are not going to get reliable shear parameters and consolidation parameters from that kind of a sample. So let's I think let's understand why we are sampling, for what purpose, and let's try to adapt our approach accordingly. I believe that if you have hard strata and value more than 30, Shelby tubes is really of no consequence. It doesn't help you. There are other samplers which are available. These days, for example, we are using Maizière samplers, and we are able to sample. We are able to retrieve very good quality samples, even in sand below water table. We are able to get fairly good quality samples for testing. So uh, sampling is important. Wrong samples will give you the wrong results. Uh, Same way with rock drilling. We have uh, a lot of equipment which is being used for rock coring. If your project has got shallow rock or your foundations are expected to bear on rock, characterizing the rock mass becomes very important. The better you characterize the rock mass, the better you can understand the behavior under foundation loading. Uh, in India, we are seeing a lot of kind of rigs. Many people are using calyx rigs with single tube core barrel. Many people are using locally fabricated rigs. You see, you have to have the right tools for drilling. If you don't use the right tools, you will end up getting a report which is not representative of the actual conditions at site. In terms of what we recommend is we recommend very strongly, we recommend that we should only use in cases where rock drilling has to be done. We feel that we should only use hydraulic core drilling rigs with double tube core barrel as a minimum in case you have fractured rock, weathered rock conditions. Please spend those extra couple of rupees and go for triple tube core barrel. It will make a huge difference in your output. And to emphasize that, we actually wrote a paper on this as well. This is the same site, and I won't go into this in too much detail. Same site, the figures on the left, the blue is the results of an investigation at the same site in rock using a calyx machine with a single tube core barrel. The same site, when we came back and the client had some problems, we went back, we reinvestigated using the proper tools, using a hydraulic rig with triple tube core barrel. You'll be amazed. The entire characterization changed. What was earlier in the earlier report, what somebody had defined as being severely fractured rock and designed it almost like a dense sand layer, the same rock turned out to be very, very good rock, only slightly fractured, very high core recoveries, very high RQD values, and your entire your bearing pressures, your construction methodology, everything changes based on this. And cost changes for the same project. And we worked with the customer, we did a quick math, and we realized that just by putting in what, maybe I think you spend 12-15 lakhs on this confirmatory investigation, the direct impact of the results of this confirmatory investigation was almost 2 crores. That's only in the cost of the foundation, only in material cost. You forget the time and everything else. So that's that by itself. I promised you I'll show you some case studies. That's a 1200% ROI. You talk to an investor and he'll be like, hey, that makes sense. Do it. So uh, I will get into talk about 510. I want to talk about in situ testing. Going forward, as the projects are getting bigger, our time is getting shorter. I think we need to change our approach. Boreholes is not investigation, and investigation is not boreholes. There is a host of other techniques. There's so many techniques which are available where you can carry out in situ testing, field testing, and you can characterize the soil in the field. There was recently at DFI there was a presentation by Dr. Madhav, and I would like to quote him. He said something very nice. He said that there is a difference between soil and ground. Soil is that small sample which you take out, maybe from a borehole or elsewhere, and you test it in a laboratory and you come up with a result. But soil is not ground, and your structure is not going to be sitting on soil. Your structure is sitting on the ground. The ground is affected by various things. The soil is not going to be homogeneous, isotropic, so on and so forth. There are going to be lateral variations. There are going to be vertical variations. There are going to be variations in the groundwater table. There are going to be so many factors which we have to understand before we conclude if our foundations which we are designing are safe for that particular site. Uh, and I honestly believe that in situ testing is one of the best ways to understand the ground, whereas lab testing is good for understanding the soil. And both of these have to go together. Uh, in terms of in situ testing, so I think most of us are familiar with, the standard penetration test, DCPT, plate load test, cyclic plate load test, block vibration test. This is what people used to use. And this is what, maybe even 20, 30, 50 years back, most of the investigations were done using this. Uh, we then moved last, I would say, 20 years. We have moved to use of mechanical cone penetration tests, some pressure meter tests. We moved from block vibration to carrying out downhole crosshole seismic tests. So there is some improvement which has happened. But now, a lot of projects, we are changing the scope. We have come up, we are doing a lot of piezo cone testing, and we'll talk about that to replace the mechanical cone. Footing load tests as a better form of doing a plate load test, I would say. There's a Makati, which is DMT, which is not very popular in India yet. Cyclic pressure meter testing, SASW. So there are a lot of tools, and it's important to understand these tools and see if we can use these tools on our next project to our advantage. This table was actually, I picked it up. I think this is from the CPT manual. A lot of these methods are available. It's like, it's like working in the kitchen. If you're cooking, you can have a masaldan of, different type of masalas available to you. So these tools are like that. They're different masalas. Lal mirch, wal mirch, sab kuch hai. But it depends on, it's for the chef, it's for the cook to decide which masala to use in which recipe. It's not that if you say ki CPT is good, it's not like sab jagah CPT chalega. You can't do that. It depends on your site. If you have a soil site, maybe with loose soils or liquefiable issues, CPT might be a fantastic tool. If you have a rocky formation, CPT will not work. So we have to understand each of these in situ tests. And once again, we have to plan our investigation based on our site and based on our expected strata conditions, based on the anticipated loading conditions. Let's talk about the CPT very brief, not very briefly. CPT is fairly new, and the last 2 or 3 years, I think Sanjay, along with a lot of other consultants, we are making a big push for CPTs in India. We're literally pushing CPTs in India. And why is that? Number one, CPT is very quick. If you're doing a borehole investigation, say, as an example, if you want to do a 30-meter borehole, the time and cost of mobilizing a drilling rig, drilling that borehole, sampling, transporting the samples to the lab, doing the entire spectrum of lab testing. So this is easily a 15 to 30-day effort before you get some kind of data for the soil report or for the foundation analysis. The CPT is a fully instrumented in situ test. So you can do a 30-meter, 40-meter sounding in just under an hour on site. The data is all digital, it's software driven, and you can get your foundation recommendations in a matter of just a couple of hours. It's you input and output. Quick is not the only thing. The CPT, and we'll see this, the CPT is also substantially more accurate. Your SPT interval is about 1.5 meters normally. CPT data interval is only 2 centimeters. So it's continuous profiling. There is little chance of missing if you have a loose seam or a thin layer in between. A CPT will catch it, whereas boreholes and other tests might miss it. And we will see how the CPT results, I'll show you how they're correlated to almost all geotechnical parameters and how they can directly be used for analysis as well. Just a side note, the CPT is covered under the code. It's currently already covered in the 1892. And in fact, I am a member of a committee, a BIS committee. We are now in the process of coming up with a fresh code, particularly for CPTU or for piezo code. This is what we used to use. This is a mechanical cone, which in India many people have used in the past, and you get analog data. The improvement to that is the use of a piezo cone, which is an electronic cone. It kind of looks like this. This is the cone. It's very simple. The cone is instrumented. It's got load sensors on the sleeve, on the tip. It's got pressure sensors. And this cone is hydraulically pushed into the ground at a constant rate. Simple as that. A lot of these slides actually are hidden, but so I'm just skipping them. I don't know why they are still being presented. So this is the CPT, right? So if you do a regular investigation and you want all these parameters, you want your shear wave velocities, your SPT value, strength parameters, your stiffness parameters. Usually you would have to do a lot of different kind of tests on the same site at a large cost. I love the CPT because in single push and with the right tools, it's possible to get all of these parameters at the same time at the same location. And we'll see how. The only limitation of CPT is you can't push CPT cone, obviously in hard strata. If you have gravel or rock, you can't push it. So this is one limitation. But you see how this is the kind of data you get. You get a tip resistance, sleeve friction, pore pressures. And you also get your soil behavior type. It's fairly accurate and very repeatable. Doing two boros at the same location, the SPT values will almost never match. But if you're doing CPT soundings at the same location, we have done this, it's accurate to about 0.1%. Its repeatability is there. We have done CPTs up to 50, 60 meters. It depends on the kind of soil with a 20-ton pusher. And these days in North India, in the alluvium, it's not uncommon. We are able to push 30 to 40 meters using the CPT pusher. Sorry, I'm jumping slides. Just in the interest of time, I want to take questions. But you also, the CPT data is directly can be used to identify the type of soil. It's not really soil type in the mechanical sense. We call it soil behavior type. But this is very well correlated. If you push a CPT, you get your soil behavior type. You drill a borehole next to it. We have done this, and we are doing it for all our sites. We see fantastic correlation in terms of type of soil or soil identification. Apart from that, you can also see this is the sample data. This is what a CPT report looks like, by the way. So this is what you measure: the cone tip resistance, friction ratio, pore pressure. You get the pore pressure through a pore pressure transducer, which is in the cone, and you get your soil behavior type. You see how accurate this is. In this data, for example, I can see. You look at this guy here. This is a thin layer of clay right here, right? What happens in the clay layer? Your cone tip resistance reduces because it's clay, it pushes through. Your friction ratio suddenly increases because it's cohesive. And your pore pressure increases because it's got a low permeability. And it classifies as clay. Now, this is something which almost certainly would have been missed in a borehole investigation, unless you're lucky enough to get a sample right here. So, that's the advantage. You also, in the software itself, or you can make an Excel file for this. It's very simple. The CPT results are directly correlated to almost all geotechnical parameters, and the correlations are very strong. For the sake of acceptability or comfort, we also present SPT correlations. And if you have boreholes in that area, we always plot the SPT values measured, that's the red values. The red dots, these are the actual, the recorded SPT values, and the black line is the interpreted SPT N value and 60 value from CPT data. You see how well it matches, to the extent that these days, I actually believe in the SPT correlations from CPT more than I believe in the SPT values themselves. But you can also get permeability, Young's modulus, relative density, friction angle, constraint modelers, shear strength. And this is a geotechnical paradise. All the shear wave velocity state parameters, all the geotechnical parameters neatly organized is something you can get from CPT sounding. Uh, Liquefaction analysis, of course, I've always held that, and this is internationally accepted. I think CPT-based liquefaction analysis is most robust. If you have a site where you're suspecting liquefaction, please definitely carry out CPTs because the results which you get will be much more robust, much more trustworthy as compared to any other investigation tool. Lastly, in a CPT, you can also stop the cone and let the pore pressures dissipate. And that is called a dissipation test. How this helps is you also get a lot of your consolidation parameters in situ. So rather than doing a falling head permeability test in a borehole, you can do a dissipation test in a CPT, and you get some fantastic in situ KH values, CV values in situ. Very good for soft clays, fantastic for soft clays. That said, globally, people don't really go from CPT data to conventional geotechnical parameters and then do analysis. If you think about it, a cone is kind of, pushing a cone is kind of like driving a pile. So many years back, the Dutch quickly figured out that the CPT results should directly be applied for foundation analysis. And it's covered in our IS codes as well. In fact, not only that, it's supposed to be very good. The CPT-based correlations are supposed to be very robust for foundation analysis, and we do this now. We use our CPT results to predict foundation settlements. We have compared it with conventional analysis, found a very good comparison for all our projects. You can carry out pile capacities. You can estimate safe pile capacities from CPT data, and once again, you can compare that with your conventional CFI analysis. You'll usually find a very good comparison. CPT-based results are often higher, but we won't get into that. And if you're doing ground improvement, obviously, I think CPT-based, QA/QC is very important. Bhavin, hi, I am having a problem. I hit slide 100 and it won't let me proceed. I think there's
just a minute.
I made too many slides.
Okay. So is it your last slide?
No, it's not. A couple of more, but
okay. Actually, it shows that you have total 100 slides here.
Oh, interesting.
That's why. Yeah.
Okay. Can I share my screen?
Yeah, sure. You can share your screen. Yeah.
All right. Hold on.
Yeah.
While I do this, there are some questions.
Yeah. So there is one interesting question from Anuj.
Yes.
Of course, it's a big question. He said, that.
Big question. Wow.
Yeah. So, So what is the scope looking like for geotechnical engineers in India in the next 10 years in terms of labor demand and number of projects? I can confirm that there is a huge shortage of geotechnical engineers. Yeah, got it.
Got it. Anuj, hi. I'm not the best expert. Nobody knows the future. But what I can say is I think there is tremendous scope. When I started off 15, 20 years back, things were different. We had fewer projects, smaller projects. Many people, there were fewer consultants, fewer geotechnical investigation companies. These days, there's tremendous scope because you can be a geotechnical consultant, you can be an investigation company, or you can even be a ground engineering contractor, right? So these days, because a lot of projects, like I'm working in places like Mundra and Khabra. Bhavanji will know these areas where you have some horrible soil. You're working in red sand, you're working in, ridiculous ground conditions. But we have to build. We have to make wind turbines on this poor soils. We have to make power plants on this poor soil. And this is the role of the investigation engineer on these kind of projects specifically has really increased over the last couple of years. There's a huge demand. There's so many companies, I don't want to mention names, but there's so many major contractors, investigation companies, and we're all growing together. There's a huge demand for geotechnical engineers. So if you love the field, I think definitely go for it.
Yeah, good. Yeah.
All
All
right.
right. So,
So
so you can
I
just.
help me. Bhavanji, it's already 5:24. So
Hmm.
I'm going to go quickly because I really wanted to focus on questions. Can you see this screen?
Yeah,
Tell me.
the pressure meter test.
Thank you so much. All right.
Yeah.
So I'll work off here. So we
Yeah.
finished CPT, right? I just quickly want to touch upon another one of my favorite institute tools, the pressure meter. Uh, it's a lovely tool, actually. You'll be surprised, actually. Uh, so, for example, if you go to France, uh, almost all their investigations are done based on pressure meters. They would be aghast if you tell them that we want to do boreholes with SPT only. They're like, how can you design without pressure meter? Uh, why is the pressure meter important? Uh, it is till date, and to the best of my understanding, it's one of the best methods to estimate your deformation modulus of your soil, your E value, your Young's modulus, uh, among other parameters. And why is that? Because you're actually mimicking the your okay. So first, how you do the test? You make a borehole and you take a probe here. There's a simple probe like this. Think of it like a balloon. You put it in the hole and you inflate the probe. Simple as that. And what you get is you get a pressure versus volume graph like this. It's very simple. Naturally, the slope of that graph would correspond to the deformation modulus or correspond to the stiffness of the soil around the probe. Uh, it's very good test because it's in situ. Usually, we in geotechnical, we estimate the E value based on any number of 1,000 correlations which are there with N value, with this, with that, or we get it from UCS values, and all of those correlations have a lot of limitations. In fact, if you actually plug in correlations from Bowes and Teng and other places, you will find that sometimes there's 100 times difference in the E value which each of the correlations predicts. How do you choose the right E value? We usually end up either overestimating or underestimating E value. And the E value is, as we discussed earlier, it's the most critical parameter for predicting, serviceability criteria, for predicting settlements, for predicting deformations. Uh, so, pressure meter, since it's a physical test, it's done in situ. It's a large strain test. I do believe that this gives you one of the most robust estimates of deformation modulus which is out there. Uh, I want to just show you this slide, just to emphasize what we talked about. We did this a project in Cuttack. This was with L&T, I think, where we did boreholes, we did some mechanical cone SCPTs at that time, and we did some pressure meters. And then we, as an exercise, we calculated the elastic modulus profile based on each of these uh, methods for the same site. Now look at this. This guy here is the regular, the empirical, E value which we get from N value, which is a normal 2.5 times N plus 15, which is given in Bowes. So this is what we get, and this is what most of us are using for our analysis. Your SCPT based deformation modulus is this line here, and the green triangles are the deformation modulus values you get from pressure meter. Now, most of you would have already noticed, if you look at any one depth, say at 12 meters, the difference between the deformation modulus is almost 3 to 4 times. Now, that's huge. What that means is that if I design based on these E values, my bearing pressures would be 25% of the actual available bearing pressure in the soil. So, this becomes very important. Uh, So if you are doing underground structure, you're doing retaining wall design. If your bearing pressure is a problem, stiffness is a problem, deformation is a problem, I think this is a worthy investment on most sites. And you can do the pressure meter, unlike the CPT, you can do this in soil as well as rock, at least weathered rock. You can do this test. Uh, Geophysics is catching on. I would like to caution, although we do a lot of geophysical investigations in house. Uh, we always like to caution that it's never any one test. You can't just do CPTs without doing boreholes. You can't just you have to have a combination of different tests, different tools, and so you can come across the way we did here, so you can actually reach a conclusion. Same way, geophysical has a lot of advantages in terms of time, in terms of access, uh, but it's not the holy grail. If you want to use geophysical investigations, use it, tailor make it for your project, but always correlate it with conventional geotechnics as well. Just quickly, I will not go through this in too much detail. Uh, that's not the agenda of today's talk. But if you have high wind loads, if you have a lot of dynamic loads, machine foundations, uh, vast improvement on the block vibration test or the cyclic plate load test. These days, hardly anyone is doing that. Usually, we are doing cross-hole seismic testing. We make 3 boreholes. We lower a triaxial geophone in one borehole and lower a PSV source in one borehole, triaxial geophones in the other 2 boreholes, and we make an impact. It's very simple. It's distance divided by time, and you can actually measure your shear wave velocity, compression wave velocity. From that, you can get your dynamic modulus values and dynamic soil parameters for design. Uh, this is obviously makes a lot more sense as compared to doing a surface test like a cyclic plate load test, which will have a lot of limitations. This will actually give you a profile. It's very good for liquefaction analysis, for machine foundation design, and so on and so forth. Small point: please never do a cross-hole seismic test without asking for a borehole deviation survey. I I always like to emphasize this because remember we are measuring the time that the wave takes to arrive in microseconds. Itna accuracy, right? But it's ultimately distance divided by time. So the distance between the one borehole to the other, we do not know. Normally, people will just put 3 meters or whatever the surface distance is. But boreholes are never vertical. They will always deviate in all kinds of directions. So doing a deviation survey is very, very, very important. It's also recommended by the ASTM code because without this, your cross-hole seismic test results will be highly inaccurate. Seismic refraction test is great. I see this test being abused a lot also, unfortunately. But if you have a site like we did the site in Delhi Metro, where you have your rock outcrop is varying, and you want to figure out, the variation in the depth of hard strata, refraction testing is fantastic, as long as you can correlate it with your in situ borehole data as well. Resistivity testing is also another way you can do a ERI or electrical resistivity imaging. It's another geophysical method. Also very good for site characterization. Very good for even you can use this for figuring out if there are voids in the ground. Very robust. And then there are other surface geophysics. There's SASW, which is spectral analysis of surface waves, or multi-channel analysis of surface waves, which are available to us. Quickly moving on, I want to talk about foundation testing. Remember, we said that no matter what you do in design, you will fail if you can't translate the design on the site. We do a lot of static pile load tests these days, and this is conventional. Most people know about this. But I think it's also very important to see the pile will either fail geotechnically or structurally. So we have to check for both. Structural failures in the pile can be tested, and there are many methods available, many NDT tests. So they have the pile integrity test, which is a very simple test. You put an accelerometer on top of the pile and you hit a small hammer. It's a very simple test based on wave mechanics. It's a low strain test. You can even get a profile of the pile, a theoretical profile of your pile. For board piles, I think doing a pile integrity test is mandatory, should be mandatory for 100% piles. Every time you do board cast in situ piles, just to check and make sure you have structural continuity, structural integrity is intact. I do want to caution you though that if you're doing foundation testing, you might as well do it right. Once again, like the way you talk about investigations, let's not go for L1. Select a testing partner whose report and whose results and whose processes you can trust. Otherwise, you'll simply get a report which is generated. Pile is okay. Pile is okay. It makes no sense. It's a waste of money. Another test for piles for structural integrity of pile is a cross-hole sonic logging. A very good test. The only disadvantage is that you have to put access tubes in the piles. You have to pre-select the piles. But you can put your probes down the pile and you can get a fairly good idea of shaft continuity using this test. Uh, an alternative and a very good alternative to static pile load test is the dynamic load test. And this has been around for many years, more than 50 years. It's been around, it's used globally. We are doing a lot of this. Right now, we're doing this in Pune Metro, in fact. So the dynamic load test, I think, is also another good technique. Uh, Again, it's very fast, much cheaper than a static pile load test. Uh, and the other advantage is that unlike a top-down static pile load test where you only get a load settlement curve, right? Here you actually get a lot of other data as well. You can actually get your an idea of the pile integrity, structural integrity, and you also get an idea of your shaft distribution versus your toe resistance, something which you don't get in a conventional top-down test. The only disadvantage of this test is that you need a solid partner because otherwise, it's garbage in, garbage out. So, uh, if you want to know, I just want to touch upon this, but we have done a lot of tests where there is an existing building and maybe you have a TBM going under the building, and they don't know the length of the foundation below the building. So there are NDT methods like the parallel seismic which are available to figure out the length of unknown pile foundations. Uh, we core a lot of piles also. Sometimes your NDT methods are not sufficient, and you suspect some structural integrity issues in the piles. We have cored piles down to 60, 80 meters. And you know what? Sometimes when you do that and you get the results, it's very discouraging because then you actually see how much can go wrong in particularly in board piles. You see crushed concrete, you see soft toe conditions, and it's scary. It's very scary for us, but it's important to test. uh, I'm going to end here. Thank you so much, Bhavin. I'm very keen to take questions, so I hurried up in the end. So,
Okay, great. Excellent presentation. Yeah,
thank you so much.
most welcome. Yeah, so let's take up the few points. Okay, I want to know about the type of test for proposed cement concrete road on existing flexible pavement which is worn out and need to be scrapped, and ESWL criteria for field CBR and borehole spacing. Of course,
Tough question.
we have not talked about this area, but yeah.
Yeah, I'm not sure what is ESWL. Sorry, I'm ignorant about this,
Mhm.
Mr. Rajiv. But I don't want to comment on scope, sir. Remember what we said is the scope has to be tailor-made for your specific requirements. I do not want. I'm always very hesitant to give ballpark answers. Does field CBR Kaldo without understanding what we are doing and what is the area we are talking about. That said, generally speaking, I think the normal practice is to do field CBR tests. You can do it either by TRL method or by the plate method. More important is to take, if you are designing a subgrade, take bulk samples, do a proctor test, recompact the sample and do a soak lab CBR test. I think most of the design is done based on soak lab CBR.
Yeah, he's just
I
clarified. ESWL is equivalent single wheel load.
understood. Sorry.
Okay.
Uh,
Okay.
we can talk offline, Mr. Chauhan. I would be happy to understand your project and then suggest scope. I said earlier, we do this at no cost with a lot of people. We are keen to do it. So if you reach out, I don't know, I'll share my email address separately. Please reach out. I'll be happy to work with you on this.
Yeah, I think we have discussed this in a brief detail. That what shall be the numbers of boreholes? This is a common question we get.
It is a very common question. We get this all the time, and to be honest, to be fair, Mr. Acharya, it's not a trivial question. It's not an easy question to answer. In fact, recently we were working on the BIS code also 6403 in 1892, and we did have a problem because we really wanted to give some kind of guidelines for the scope, right? But we were very hesitant because like a guideline guideline दे दिया, तो then people will use it in different kind of ways. It's a hard problem. The current code, if you look at it, it does specify. I think it says 4 or 5 boreholes every zero point 0.4 hectares. It works out about a 50-meter grid spacing.
Yes.
So that is something. It's not, I don't want to say boreholes. I want to say tests. Again, remember, I'm moving away from boreholes, right? But 50-meter grid spacing for most projects is a good thumb rule. But again, you have to tailor make it for your project. If you have a high-rise building, for example, the high-rise building code is different. And the high-rise building code gives you different recommendations. For each tower, you need like 3 to 4 investigation points. And it specifies the depth of the borehole as well. It depends on where you're building it. Is the formation uniform? You can do away with fewer boreholes also. If you are expecting some geotechnical complexity, I would recommend either increasing the number of testing points or increasing the number of type of tests that you do. And this has been the thrust of the entire presentation today. Again, going back, I'll say the same thing. So please, if you have these questions, send me your project details. I would be happy to work out your scope for you free of cost. This is our passion.
Yeah. So in fact, the questions were raised, towards the presentation. So I think he might have raised.
No problem.
Okay, Krishna is telling, sir, can you brief about Tank's formula which has been used for SPC?
A very academic question, ma'am. If you don't mind, we'll skip it or take it separately. Yeah. I'm a very practical engineer. I don't want to get into mathematics.
Okay, Suresh Kumar is asking.
We have free hands to go for 5 lakh for soil investigation. Auger method, maximum 50. We can have a free hand to go for a 5 lakh for soil investigation with auger method, maximum of 15. I didn't understand the question.
Yeah, I think
it does. I would like to comment, Mr. Suresh Kumar. It looks like there's a lot of constraint which is given by the management, it seems, on what they can spend. Do go back to them and tell the management that this is not the way to approach engineering. It should not be a top-down approach. It should be bottom-up. Understand the problem statement, understand the value of what you're doing, and the value of what you can save based on what you do. And let's look at the big picture. 5 lakhs for any project is nothing, right? It is nothing. But this 5 lakh, if it's going to influence 5 crores of your project cost, then you have to spend a little more. You have to take it a little more seriously than this.
Yes.
Yeah, I don't think you can go 15 meters with auger borehole either.
Okay.
Liquefaction analysis criteria we have to take either significant criteria or shear load criteria. I don't know, Mr. Ashok Kumar. I'm sorry. I do understand liquefaction well, but I don't understand significant depth criteria or shear load criteria. Are you talking about liquefaction susceptibility analysis, or could you elucidate on this?
You can elaborate it in more detail in a second part.
Yes.
We can take it. Okay. And pore pressure measurement in earth dams and rock-fill dams by piezometer.
Yes. In earth dams, great idea. Rock-fill dam, I don't think you can't push the cone in rock, as I said earlier. So in rock-fill dams, you may not be able to get good data. But I was reading up a lot of tailings dams and a lot of earth dams worldwide. People are rehabilitating these dams and levees. So I think piezo cone investigation is fantastic for such cases. And thank you for pointing it out, because pore pressure measurement becomes very critical. Even if you have a non-hydrostatic pore pressure distribution, you can measure that using a CPT test. You will not be able to do it using conventional geotechniques. So good. Yes.
So can we find out?
Sorry. Yeah. He said piezometer. He didn't say piezo cone. You can do pore pressure measurement, of course. Using piezometers, you can do it. That's not a problem. You can have either sandpipe piezometers, Casa Grande, or vibrating wire. There are many piezometers available. Then I think, yes, it's very important. He's talking about field monitoring. Very important.
Yes. Difference between initial and routine pile load test.
The initial pile load test is before you start your actual piling process. Normally, you install a couple of test piles outside your construction area. You think of it as proof of the pudding. पहले तो soil report में हमने कुछ तुक्का मारा कि भाई this dimension pile will have so much design load. Now, because soil is a complex structure and we don't really believe anything, so we make a sample pile, we test it on site, and that's called an initial pile load test. Once that test is done, ideally you should iterate your design as well. But in India, we are not doing that. We do pass or fail. If it fails, we'll fire the contractor or the consultant. If it passes, then we will approve the design and we'll go with the routine pile load test program. The routine pile load test is there's in 2911 part 4, it recommends a certain percentage of your production piles which have to be tested just to make sure that the production piles are achieving the required design capacities.
So the important part will be the timing, because in many projects the routine pile load test will be done in a later stage, right? And up till that
Yes.
stage, number of piles are already executed. So then we have to take.
You are right, sir. In fact, very often people don't do the initial pile load test. Or they don't do the routine pile load test on time. You're right. And when they actually do it, then the problems come, and by that time the piling is done, and there's nothing they can do about it. And then it becomes a huge issue. I think, honestly speaking, I think we approach, and I touched upon this. We approach, especially for deep foundations, we don't understand the importance of QA QC in deep foundations. The way we are approaching it in India is, we get a soil report, a capacity aaya, we'll catch hold of a piling contractor, select as usual on L1 basis, and we'll put the pile testing in the piling contractor's scope. Piling contractor will get a testing agency on L1 basis, and he'll say, pass report chahiye, to paisa milega, right? And this entire ecosystem is very bad for the project and for the project owner, because he'll never get the right input at the right time, and when problems happen, litigation se kuch hoega nahi. The correct way to do it is, you must have first a good design report, actually carry out an initial pile load test. I always recommend for the initial pile, do your pile integrity test, do a static pile load test, and also, if possible, do a dynamic pile load test on the same pile. Make a correlation for that initial test pile. Understand the test results. Go back to your design. If you have to fix your design, either you have to increase the capacities, decrease the capacities, do something, do that now. Then develop a proper document, which is a QA/QC document for that project. It should specify clearly what is the percentage piles that have to be tested. For structural integrity, you can do PIT. Normally, I suggest 100% PIT, 20% cross-hole logging, 5% dynamic testing. And, if you're doing more dynamic load tests, you can even reduce the number of static routine pile load tests. So for the same price, in lesser time, you will be able to test far many more piles without disturbing the construction schedule. People don't do routine pile load tests because they feel ki kaam ruk jayega. But you have the option of doing dynamic load tests while the piling is happening. So do that. At least you get feedback at the right time.
Yes. Appreciable and commendable presentation. Okay.
Thank you.
Kindly comment upon based geotechnical testing for uplift resistance of normal paid foundations used for extra high voltage power lines. Tower height is around 80 meters.
Best geotechnical testing for uplift resistance of a normal pad foundation. So I think you're talking about geotechnical investigations.
I think he's talking about establishing the level of groundwater table, probably.
Maybe. Mr. Pradeep, I didn't fully understand, but if you're talking about investigations, then, regular, again, I go back to my standard dialogue. If you're doing, I think this is a transmission line project, the investigation program will depend on, where you are building a transmission line. If you are in MP, you're going through rock, right? I would say, you have to do rock coring. Maybe you go 3-5 meters into rock, characterize the rock properly. If you're working, no investigations, yes. If you're working, like right now, I'm working on a transmission line project in Khavda, which is very poor soil conditions. So there, at least I suggested to the customer that please don't bother doing boreholes along the transmission line at the tower locations, do piezo cones, do CPTs. It's a lot faster. You get better data, and you get continuous profiling for design of piles in that case. I don't think I'm not sure if I answered your question, but share the project details, and I would love to work with you on designing the scope. Quite a widespread line, cross country, fast. Yes, there are fast investigations, and depending on where you're going. If you're going, if you have a soil site, as I said, I give you the Khavda example. You can do in situ investigations. You can maybe do a couple of boreholes and do CPTs at the same location to cross correlate, and then in between you can just do CPTs as well. In some places, you can also do geophysics, depending on where your line is passing through. If you are expecting that your rock level is varying, and that is going to be important for your, that's the most important variable for the design of your transmission line towers, then I would say do a couple of boreholes and do maybe a refraction testing along the line. It's very fast, very, very fast.
What is the most appropriate method on hills when BLT is not possible?
I'm not a very big fan of plate load test, Mr. Ravinder. I think plate load test is like SPT. I think it's on its way out. Hopefully, plate load test has got many limitations. On hills, it depends where we are working. What is expected strata? I think doing regular boreholes is usually the way to go. If you have a very tiny structure and you can see that it's good bearing material on the surface, very often a simple site visit coupled with a couple of test pits might also be sufficient. But if you're building something a little more ambitious, or the soil conditions are a little more complex, or if you have slope stability problems, then we need to look into the project and design a investigation program specifically for you. The plate load test, I don't know. I'm not a big fan personally.
Can you arrange a practical program on field test related to geotechnical engineering project? It will be helpful to all upcoming and present geotechnical engineers.
I'm always keen, sir. I'm always keen if somebody gives me a channel. We have sites going on at all points of time, and as a company, as I said, we are always very interested in doing new things, in sharing knowledge, all of us. So I work with IGS Delhi chapter, and we have been talking about we have done some field visits and some field programs in the past, some field demonstrations in the past. It is a big country. I don't know where you're from, but if you have a requirement, get in touch with me. If I have a site going on close to you, I would be happy to, take on a field demonstration. But somebody has to help me organize it. So, in Delhi, I can take care, but in other places, if somebody is interested, I would be more than happy to bring the equipment and give field demonstration. It's our passion.
Great. I am still structural engineer, mostly dealing with superstructure design. Any book recommendation that explains the basics of foundations and geotechnical engineering?
So there are a lot of books. I haven't read most of them, but I really like the book by my professor, Professor Shashi Gulati. He's written some very good, very simple book on geotechnical engineering. Then Bowles and Peck and Hansen. There are a lot of standard geotechnical textbooks which are very good. But these days, to be very honest with you, sir, I think attending interaction sessions like this and webinars and YouTube videos, these days this has become the common currency of knowledge. So, I don't remember the last time I picked up a book, to be honest with you.
Okay, so that's all. So we have reached around 6 p.m. now. So
Right on time.
Yeah. Okay, how much MASW results are reliable?
when I talk about reliability, sir, I always, I never blame the test. I want to emphasize this. Very often I see a lot of questions. ये PDA कितना reliable होता है? PIT, MSW.
Yeah.
The test, we always blame the test. The test is always reliable. Each of these testing tools, there's nothing wrong with the tool. There's nothing wrong with the test. गलती कहाँ आता है? The person doing the test or the person interpreting the test results. This is where human errors, or you will have a human error in terms of using the wrong test at the wrong situation. If you're doing so that is it. This is the only limitation. If you have the right guy doing the right test for the right purpose and knowing how to come up with a correct interpretation, there is no problem with reliability. हम लोग का सारा reliability issue is human reliability. So we talk about pile integrity, but I always say, boss, look at the human integrity first. There's nothing wrong with pile integrity. If you have an agency वो 300-400 रुपए में कर रहा है pile integrity, just pile is okay, then that is not a reliable agency. The test is still reliable because I have used pile integrity test to solve many complex issues also, simply by understanding what the data means. So if we take away anything out of today's presentation, repeatedly what we believe is, it's not about the tool or कौन सा खरीद के आप कौन सा test कर रहे हैं. It is about understanding what you are doing and understanding how to interpret and move forward. I can share my mail address.
Yeah, you can just speak. I'll just write down.
Yes, it's saurabh@senjus.com. SOR.
SOR.
Sorry. Can I correct that, Bhavanji? Send it to our central email. It's contact, CONTACT.
Just
Contact.
at the rate.
Otherwise, I'll get many emails. At the rate. Senjus, CENGRS.com.
CNGRS.com.
You can share my direct number also. I don't have a problem. So 99.
This is your email address.
Perfect.
Right?
Yes.
Yeah. Okay, you want to share your number also?
Yeah, 99108.
99108.
62118.
62218. Yeah, so this is the contact number.
6111.
6111. Oh, sorry.
99108 61118.
Okay, 341. Okay, I hope it is
Perfect.
now right number.
Thank you.
Okay, great. Yeah. So, dear Saurabhji, it was a nice presentation. Yeah.
Thank you so much, sir. My pleasure. We can do as many of these as we like.
Yeah, good.
Always a pleasure.
Yeah, sure. So I think looking to these the queries we have received, we can have more interaction of this kind. Yeah. So sure. Thanks for the time, and we'll collaborate definitely. Yeah. Okay.
Absolutely.
Okay. So thank you all for the participation. And raising this interesting point. And thanks a lot, Saurabhji, for giving the insights related to geotechnical investigation. And as you rightly said, that close interface between geotechnical and structural engineer is really required. And I have also experienced personally that it can, save crores and crores of rupees in number of projects if we do this activity in a proper time of the project.
Yep.
Right. Right. So certainly we can have more sessions on this area at mutual convenient time. Okay. So with this, we are signing off. We are closing this session now, and we'll be meeting again with the very interesting session. Yeah. Okay. So goodbye
Great.
from our side. Yeah.
Thank you so much. Namaskar.